I am a master student majoring in computer science, and this is pattern recognition. Pattern recognition helps us with defining or discovering which model to use based on what kind of training set we have, what kind of data we're working with. So the first one we have is linear regression. It's the most simplest of the models to use for any data set. So what we have is we plot points. No, based on the plotted points, we have a line such that the line is optimized and it's like a straight line that tries to make sure that all the points are close to it as possible or have like the least amount of distance. It's the most simplest technique to use for modeling any data set. So here's a comparison between linear regression and neural networks. With linear regression, we have one input directing it to one output with which we get the line. But with neural networks, we have layers, we have weights, we have different types of computation that happens within the hidden layer before we come to an output. So neural network is a bit more advanced, is a bit more better, and would give us a more precise answer. So we have types of linear regression where we have a simple linear regression. This is matches versus runs in a training training and testing set of just a cricket match, and how it has tried to plot the optimal line, which says that a player needs to play a certain amount of matches for him or her to have certain number of runs. This is multiple linear regression, so it's not a straight line, and we define epoch in which we can model or we can place where we want our line to be. Again, this is not a straight line, it's a bit more of a curve, and it gives a bit more precise result because it's not a straight line. Now we have polynomial linear regression, in which we don't necessarily have a curve, but we have a line that connects all the points, which gives us a highly specified result. But then at the same time, it could be that because we're trying to join this line through all the points, we can end up with a result that is too specific, and we can waste our time in trying to get the exact answer where we could have just done with the range and be done with. So this is like a salary versus level or years of experience and how it correlates. Now we have logistic regression. We have a classifier training set with exam score, and it says age here, but it's more of a score that it has given. So like a hit or miss thing, where zeros is a miss and 1 is a hit, and we have classified it into 2 different colors to get an idea of where maximum points lie. Then we have k nearest neighbors, in which what it does is it clumps nearing points together and sets it as a region. So if a certain point is closer to a certain clump, it will assign that point to that clump. We have the Hebbian rule, in which which here they've used it for assembly, as in identifying what the image is, if it's an apple or a banana. So for image classification, Hebbian rule is very helpful. Then we have the delta learning rule, which comes into picture when we're doing neural networks. With this, we can modify in our weights and get so we can change our weights and make sure that our answer is more towards what we want. So like if you're doing like an image classification and we have apples versus bananas, we can modify our weights and we can easily classify if the input image is an apple or a banana. This is sort of like a picture. We have our activation function, we have our weights, we have our hidden layers to identify if this is a circle, square, or a triangle. So this image has been wrongly identified as a square. So what we're going to do is during our training, we're going to rectify our weights. We're going to change them a bit so that it gets identified as a circle, which is right. Then we have the correlation learning rule. These are just learning rules that are a bit more in depth of what you want to do with neural networks. You just give it a read through. It's not that difficult to understand, but you won't really be using it. And with pattern recognition, if we have like multiple images, actually no, multiple patterns that is identifying within images, the model should be able to identify which block belongs into which section. Then we have pattern association, where these six images ideally are similar, but they're all different. Then we have function approximation and control, which is setting that if you're trying to identify an apple between a banana, you can just say, okay, if we have a lot of red, that's an apple. If we have a lot of yellow, it's a banana. But then if you're trying to identify between a circle and an apple, then the same rule fails because the circle is also red in color. So you need to know what is your control and what to set it as. Then we have filtering. So if you have an image, a crowded image, and you just want to identify an apple within a fruit basket, you should be able to filter out all the other noise, which is all the other fruits, and successfully identify the apple.